Okay, hey guys, just wanted to give you guys an opportunity to see how you were supposed to do the work on the quiz that you just got back. Since I'm not there, hopefully this will help and then hopefully translate over to your quiz that you're going to take today. I'm also going to go over the Bellwork that's on the board too, so if you want to see that, just stay tuned to the end of this video. So the first, I'm not going to spend too much time on outcome one because this is the second time taking outcome one. But I will say that the number one thing that kids did is they simply forgot to rewrite the expression as a rational exponent. What that means is if we do this first one here, if you remember the 216 is to the first power, so this 3 would essentially come around, making this 216 to the 1/3 power. And then you were supposed to evaluate, which means I find the answer. 216 to the 1/3 power is, I believe, 6. So that was your answer. So you had to have both of these pieces in order to get this answer correct. You had to have the change over to a rational exponent and the answer. Same thing happened here. This ended up being 3 to the 3/4 power, and then that was like 2.78 or 2.28, I think was the correct answer. This one, number 3, all you had to do was simply rewrite it in a rational into a radical expression. You didn't actually have to evaluate this one. So this essentially you're putting it back into radical form. So this would be the 7th root of 48 to the 5th power, and you didn't need to evaluate it. It just that was all you needed to do. I'm going to focus most of my attention here on outcome 2 because this is where most of the mistakes had happened, and understandably, a couple of these things we just went over right before. I was concerned that this was going to be the case since we didn't spend a lot of time on it, and I sort of just assumed that this stuff was gone over and fresh in your minds from last semester, or if not, from Algebra 1. But just to kind of break this down and just to show you what exactly you're supposed to do here, with number 4, whenever you have a root where you have variables, so notice here you have variables, you can do the 5th root of each of these separately. So in this first part here, I can do just the 5th root of 32 first. I can do it all separately. So the 5th root of 32 is just it's a whole number. You can just put the 5th root of 32 in your calculator, and you'll see that that is, in fact, 2. If you remember, with the variables, though, because of this 5 out here, I need to look for groups of 5. The x only has 1. The y has 6. And the z has 5. And so because of this 5 here, this is a 5th root, I'm supposed to be looking for groups of 5. Now, since the x's do not have a group of 5, nothing gets to come out. So when I have my leftovers here, this 5th root, the x is going to remain in the root. Now, with the y's, I do have a group of 5 here. There's one group of 5, so one group of 5 will come out. But there is one left over that will remain in the radical. For the z's, I also have a group of 5, one group of 5. So there's going to be one group of 5 that comes out. But there are no remainders, so z is not left inside the radical. And so this is actually your final answer here. Now hopefully you're going to see this outcome again on today's quiz. Hopefully that helps in doing that type of problem. The second type of problem I had here, and this was another one that was commonly missed, was when you're adding or subtracting radicals, sometimes one of the things you have to understand is that you cannot add or subtract radicals unless they are the same radical. In other words, these things right here have to be the same in order to add them. So when they're not the same, what you try to do is you try to simplify the radicals, and then hopefully in the process of simplifying them, they do become the same radical. So what we're going to do here is I'm going to simplify these radicals. So what multiplies to be 72 could be 8 and 9. And then 8 would break down into 4 and 2. 9 would break down into 3 and 3. 4 would break down into 2 and 2. Because this is a square root, what we're doing here is we're looking for pairs. It turns out that I have 2 pairs. And when you have multiple pairs, okay, right here I have multiple pairs, you multiply them. So I have a pair of 2s and a pair of 3s, which means 2 times 3 is 6. Now, this lone 2 here that's extra is going to stay in the radical. Another thing that you had to recognize is the fact that this radical right here already had a 2 out in front. So it's essentially 2 times this. So in other words, it's 2 times this. So I had to multiply by 2. So this became actually 12 radical 2. This multiplied here. Then I can bring down this one, the minus 3 radical 2, and as you may notice, they both now are the same radical, so I can subtract them. 12 radical 2 minus 3 radical 2 is the same thing as if you were doing 12x minus 3x. Well, it'd be 9x, or 9 radical 2. You're going to have one on your quiz very similar to that, so hopefully that helps. Now, most people were able to get number 6 correctly because this is one we did do in the notes and we did in practice. Remember that when they do have the same root like this, you can just simply divide the numbers. Or if you had multiplication, so if I had something multiplied here, if they have the same root, you can multiply them. But in this case, they have the same root, so you can divide these. 1215 divided by 5 ended up being 243. So it's the 5th root of 243. And then from there, that was just 3. That's a 3. And so most people got that one correct. It was numbers 4 and 5. So hopefully after doing 4 and 5 and you take the similar problems on today's quiz, we'll get mastery of outcome 2. Now, I know some of you guys, got all these right, and so some of you may be skipping ahead looking for, okay, well, what about those problems that are on the board? So I'm going to do the problems that are on the board. The first problem, okay, is the square root of 2x minus 7, and that equals -5. So this is what we talked about last class. When you are solving radical equations, there's really just 3 main steps to solving these. The first thing to do is to isolate your radical. In other words, we need to get the radical by itself. Now, in number 1, the radical is already by itself. It's all by itself on this side of the equation. So we can skip that step. The next step, step 2, is to get rid of the radical by using the exponent, the same exponent as the root. So what we have here is a square root. So in order to get rid of the square root, we are going to square both sides. That will get rid of your square root, leaving you with 2x minus 7 equaling -5 squared. -5 squared, -5 times -5 is positive 25. Once you've gotten rid of the radical, you then can solve for x. Those are really the 3 main steps there, is to then now solve for x. So I'm going to add 7 to both sides. And then finally divide by 2. Now, one thing that we always want to make sure, and I talked about this last time, is because radicals have restricting domains, we can't, especially with even radicals, we cannot have negatives in our radicals. Remember, with even roots, we can't have negatives, so it's a restricting domain. So we always need to, when we have even roots like this, we need to check our answer and make sure that it is valid. So what I'm going to do is I'm going to plug 16 back in here for x. So if you think about this, okay, let me do this in a different color so you can see this. Essentially the square root of 2 times 16 minus 7 equaling negative 5. So 2 times 16 is 32. This is 32 minus 7 is 25. The square root of 25 equals negative 5. Now, here's the problem. When we take the square root of 25, you get 5. And the square root of 5 does not, 5 does not equal negative 5. So actually, this one doesn't work. And since that was your only solution, in this case, there will be no real solutions. And that's actually all you can write if you don't have a valid solution. Sometimes you have two solutions, and only one of them is valid. So, but this case, we only had one solution, and it wasn't valid. So, and there's no real solution. The other thing that's going to give this away, if you had recognized this up before, or up at the beginning, this is a square root, and it's equaling a negative number. You may have recognized that there is no way to square root a number and get a negative. No matter what number I square root, you will never ever get a negative number. So you could have right away in the beginning said, oh wait, square root equaling a negative, that can't happen, and came to this conclusion already. But this sort of just proves it. The second question on the board, let me go back to my blue here, is a little bit more complicated. Okay, 4, and then you have the cube root of 2x plus 5 plus 6 equals 26. In this particular problem, we're going to, again, go through those steps. Remember, step 1 is to isolate the radical, so we need to get this by itself, so everything else needs to go to the other side. So first thing I'll do is I'll subtract the 6 over to the other side. So I have 4 cube root of 2x plus 5 equaling 20. Then I'll divide by 4. So I get the cube root of 2x plus 5 equals 5. Now, once the radical is isolated, I can get rid of the radical by doing the opposite. So since this is a cube root, I'm going to cube both sides. And that'll get rid of your radical. So now I have 2x plus 5 equaling 5 times 5 times 5, which is 125. This one here is you're going to subtract the 5 over. Step 3 is now to just solve for x. So that's what we're going to do now. 2x equals 120. Divide by 2. X equals 16. Now, because this is an odd root, odd roots, we don't have to check the solution here because odd roots don't have restricting domains. You can have positive numbers and negative numbers in the radical. So we don't actually technically have to check our answer because it is a cube root. Though you should always get in the habit of checking your answer, we can plug 60 back in there and find that it should give us a valid answer. So 2 times 60 is 120 plus 5 is 125. The cube root of 125 is 5. 4 times 5 is 20 plus 6 is 26. So you can check your answer, and you should always check your answer, but we don't need to validate our answer in for cube roots because they don't have restricting domains, only even roots like the square root in number 1. Hopefully that helps, and hopefully you're ready for your quiz you are about to take. You're essentially going to take your quiz on outcome 2 and outcome 5. All right. Have a good day. Check out their e-learning is up, and you should be able to access the e-learning if you want to access it early, because I won't see you on Monday either because it's e-learning. So I won't see you guys till Wednesday. Thanks.